Hi, in this tutorial we're going to look at how to convert an Inventor file from an .ipt file into a format that can be used to convert it into G-codes which are used by a 3D printer. So to do that, we're going to particularly be using the Flash Forge 3D printer, so we're going to use the Flash Print as the slicer software. So to do that, go to the top left hand button over here, go to Save As in Inventor, and save a copy as. Select that, and then you'll get a lot of selections and options here. Under the Save As type, choose STL files. Yours will probably pop up as a .ipt file if you've done a part file in Inventor Professional 2015. And go down through all these files, but make sure you select .stl, stands for stereolithographic file, and it converts the file into a format that can be digested by the slicer software. There you go. So you can save it. When you choose to save it, make sure you save it somewhere where you can find it again and where it's useful. So in your case, if you're working in a school, you might want to try and select your school profile on the school server, or somewhere where you can get access to it again quite easily. I'm going to go up to the desktop and put it on my desktop and save it. Now it'll tell me here possibly that this file already exists. Yes, because I've done this before. In your case, you won't get that error message. So we now have on the desktop a .stl file. There it is there. It's key tag and it's a .stl file, and that's the format that it's in. Okay. Now, having done all that, we are now ready to go to our Flash Print software. So open it up, or our slicer software, and I've already done this. I want to go back for a minute here now and show you guys what it looks like if we start from scratch here now. So we'll load a new project. Do you want to say in the changes? No, I don't. So what you'll be faced with when you open the software is, and I'm holding my left mouse button down to move this around. What you'll be faced with is this little object over here, and that's the print volume. So it becomes the volume that you need to look at. There it is there under Home View. Everything inside this volume can be printed. Outside that volume, it won't fit in. We're going to load up or load in our object, which is that .stl file. There it is on my desktop. Select it, open it up, and it comes in. Now Flash Print tells me it's off the platform. It's actually sitting underneath the platform. Do I want to put it on the platform? Yes, I do. So I click yes. Key tag's sitting there ready to go, but it's not really in the best position to print. It's going to print a lot more quickly if I lay it flat on this unprinted side on its back. So to do that, I'm going to rotate it. So I left click on the rotate button here, another click again. It warns me that no model is selected. Now in that case, when that happens, you've got to left click and select this model. When it's highlighted like that in that lighter color, you're ready to start moving it. And I'm scrolling in and out with my middle mouse button to create the zoom. Okay, so let's rotate it, left again. Now use the 90-degree movements to rotate around. You're going to find it's a lot easier than trying to scroll it by hand, because if it's not exactly flat on the bed, you're going to end up with problems. So use the buttons here. You can go X, Y, Z axis, so it's sitting perpendicular with the printing facing surface up, parallel to the print bed. Okay, now click on the move button and left click again. This little button down here is very useful. It says on platform. Click on that and straight away our object's on the platform. And you can see that because it's highlighted in dark blue, and that's what we want. Okay. Now you can also, in this form here, you can move it. You can move the object by left mouse button holding down to wherever you want it to go on the print bed, and that's exactly where it will print. Next stage is, when we've done that, is to climb out of there by clicking the cross button and go to the print. Click on the print tab, and we're ready to print this object. Now I'm going to need to show you the detail of this because it is a bit important. Let's see if we can get this going here now. We want to select the material on the right extruder. These are extruders, left and right, as ABS. The material on the left is going to be ABS as well, but there's no filament in the left extruder on our particular printer. Supports, do we want to enable supports? The printer can't print into thin air, so if there is some kind of suspended surface that's hanging out over the print bed, and if it's suspended at an angle of less than 45 degrees, we're going to need to have supports. So where are these supports going to be printed? Well, obviously from the right extruder, because that's the only extruder that has filament. A raft is actually, it's almost like a mat on which the object sits. Is printed on top of that plastic mat, and it's there so it increases the footprint of the object and stops warping due to uneven cooling during the printing process. So definitely worthwhile having a mat, and we're going to have one extruder to do that, and that's the right extruder. The resolution, leave it as standard. High resolution takes a long time to print. Now layers, we're going to choose, leave that as exists, our layer height. Shells, three shells on the outer layer. That means that the outer layer will be solid plastic with 3 shells, and each one of those 0.2 millimeters. So that means that the object will have a thicker skin, if you like, in contrast to the internal volume of the object, which is now filled at 20% of solid, and the fill pattern will be hexagon, and that's done to save time, to save weight, and to save cost. Speed, that's set standard at defaults to the correct speeds for the print head and also for traveling, and you've got the speeds there, leave them sitting as they are, 60 and 80 millimeters. Temperature, make sure that you will have to change this, I think, that your right extruder is heating at 230 degrees and that your platform is at 110 degrees. It needs to be quite hot for ABS because it's quite strong, high melting temperature. That all done, you can click OK. And where do you want to save it? Well, we're going to go on the desktop. In my case, you will select somewhere more appropriate for your case. Please don't save it onto a workstation when you've got 50 workstations, otherwise you'll have to go straight back to that workstation to find the part. Save it onto your profile on the school server. Here we go. It already exists because I've done this before. You won't have that problem. And you can see now it's produced what the final part will look like when it's printed. Sitting on top of that skirt, the way we spoke about, or the raft, I think it's called. There it is. And we've got on the left hand side a bunch of 29 layers to create this object. Now I'm going to go all the way down to the bottom, drag this little slider button all the way down, and I'll show you how it's printed up. So it starts off building the bed, or the raft. I call it the raft, well, it should be called the raft. And as we go up, you can see the raft crosses, and then it builds the first layer, and from the first layer you start to get the shells. Now you can see the hexagonal infill, which is building up, and the outer layer, I'll just show you that in a bit closer, is thicker. Can you see it? How that's your 3 shells, and the internal layers are thinner. So the outer skin is 3 shells thick. Okay, so we'll bring this up a little bit more, and you can see it filling up, and there it is now, just printing the surrounding areas, and the raised printing section goes up, hollow again in the middle, and then finally the print is finished. Notice up the top right hand side here, it's 37 minutes is the estimated print time, and 3.21 meters, and I think it's 1.76 millimeter thick filament, so you can work out the actual cost or weight of the filament based on the number of meters required to complete your project. Okay, that's it, and that now can be, that file which is now saved on your desktop is a G-code file, or a .g file, and it will look something like, there it is there, I'm highlighting it now with my mouse. Now that will be saved onto an SD card and pushed into the printer, and the printer will read that and then has all the information necessary to be able to create your product in a 3D printing environment. Thank you very much for listening.